Or on problem 38, which of the following best describes the graph of this system of equations? Okay, so maybe they're the same line, maybe they're parallel, maybe they only intersect in one point. Two lines intersecting in only 2 points. Well, that's impossible. 2 lines. I mean, that can happen with curves, but that's not going to happen with lines. So we can already cancel out choice D. Okay, now let's look at these two. If I were to, see, I have a y here and I have a 5y here. Let's multiply this top equation times 5 and see what it looks like. So if you multiply the left-hand side by 5, you get 5y. I'll do it up here. You get 5y is equal to 5 times minus 2 is minus 10x plus 5 times 3 is 15. So if you multiply the top equation, both sides of it, by 5, and it really doesn't fundamentally change the line. The equation might look different, but the equality will still hold in the same universe, which is essentially that line. So if you just multiply both sides by 5, they become the same equation. 5y is equal to minus 10x plus 15. So they are the same lines. So that's A, 2 identical lines. Problem 39. And they want us to simplify 5x to the third over 10x to the seventh. So the easiest way to think of this, or at least for me, I mean, well, there's a lot of ways you could do it, and we'll do it both ways. This is the same thing as 5/10 times x to the third times x to the minus 7, right? 1 over x to the 7 is the same thing as x to the minus 7. And this is equal to 5/10 is 1/2. And then here we have the same base and we're multiplying, so we can add the exponents. 3 plus minus 7 is minus 4. So x to the minus 4th power. And we could write that as 1 over 2 times 1 over x to the 4th, or 1 over 2x to the 4th. And that is choice B. Now you could have done it other ways. You could have said, okay, let's see. I have a divide the numerator and denominator by 5. So this would have been 1. This would have been a 2. And you say, okay, let's divide the numerator and the denominator by x to the third. So this will become a 1. And x to the 7th divided by x to the third is x to the 4th. You could have done that one. You had 1 over 2x to the 4th. Either way. Or you could have even said, you didn't have to go to this step. You could have said, okay, I can just, when I'm dividing with the same base, I can just subtract the exponents. So 3 minus 7 was minus 4. Either way, all of them would have been valid ways to approach this problem. Problem 40. This looks like a simplification. They write 4x squared minus 2x plus 8 minus x squared plus 3x minus 2 is equal to. So the key here is just to realize that this is a minus, right? So you could kind of view it as a plus minus 1 times this whole thing. So we're just going to have to distribute that out. So this is equal to 4x squared minus 2x plus 8. And now we distribute this minus over this whole expression. So minus times x squared is minus x squared. Minus times 3x, positive 3x is minus 3x. The minus 1 times negative 2. Well, now they cancel out and you get a plus 2. Right? We switch the sign on everything here because they're all being multiplied by this negative 1. Okay, now we can simplify. So let's take the x squared terms first. So we have a 4x squared. We have a minus x squared. So 4x squared minus x squared is 3x squared. Right? 4 minus 1 is 3. Then let's do our x terms. We have a minus 2x. We have a minus 3x. So minus 2 minus 3, that's a minus 5x. Minus 5x. And then last we have our constants. We have 8 plus 2. 8 plus 2 is 10. So 3x squared minus 5x plus 10. And that is choice D. Problem 41. Okay. They say the sum of two binomials. Let me copy this one. This is interesting. The sum of two binomials is 5x squared minus 6x. So binomial is just a polynomial with two terms. if one of the binomials is 3x squared minus 2x, what is the other binomial? So they're saying that, so this binomial is one of them, so they're saying 3x squared minus 2x, and when you add that to some other binomial, and I don't know, let me just write that as I mean, there is no constant term here, and there is no constant term here. So I'm assuming that and it has to be a binomial, right? There's only two terms. So I'm assuming my two terms are an x squared term and an x term, because that's the only terms that are involved in both of these. So let's say my binomial is ax squared plus bx, right? This is the mystery binomial, and their sum is equal to this up here, is equal to 5x squared minus 6x. Now let's see what we can do. Well, this is a plus here, so the parentheses really don't matter. We can rearrange this as 3x squared plus ax squared minus 2x plus bx is equal to 5x squared minus 6x. See, 3x squared plus ax squared, that's the same thing as 3 plus ax squared. And then minus 2x plus bx, or we could switch them around. That's the same thing as plus b minus 2. I just took the coefficients, added them together. X. I switched them, but we could have written this in the other order to begin with, is equal to 5x squared minus 6x. And now you just compare, okay, 3 plus a, if you just look at the x squared terms, 3 plus a has to be equal to 5, right? Because that's the coefficient on the x squared term. So 3 plus a is equal to 5. Subtract 3 from both sides, you get a is equal to 2. And then we have b minus 2. b minus 2 has to be the coefficient on x here, so it has to be equal to minus 6. Add 2 to both sides, you get b minus 6 plus 2 is 4. So the other binomial, just substituting by ax squared plus bx, is 2x squared, right? 2x squared plus bx. Oh, sorry, this was a minus 4, right? Minus 6 plus 2 is minus 4. So plus bx, so minus 4, that's bx. And that is choice A. Next problem. Next problem. Okay, they say which of the following expressions is equal to, this is problem 42, and they write x plus 2 plus x minus 2 times 2x plus 1. So we had to simplify this, and remember, order of operations, multiplication comes first. We have to multiply these two expressions first. So let's do that. So this is, I'll rewrite this one over here, x plus 2 plus, and now let's multiply this. So this is really, when you multiply these two binomials, you're really just doing the distributive property twice. And let me show that to you. So this is, we could view this as x minus 2 times 2x plus x minus 2 plus 1. So I'm just distributing the x minus 2 times each of these terms. So I could write this as x minus 2 times 2x plus x minus 2 times the 1, right? All right, now we can just simplify that by doing the distributive property again. So this is x plus 2 plus, let's distribute the 2x times each of these. 2x times x is 2x squared. 2x times minus 2 is minus 4x. Plus, well, we're distributing a 1. 1 times anything is just itself. So plus x minus 2. Plus x minus 2. And let's see what we can do. We only have one x squared term, so let's write that down. 2x squared. So 2x squared. And then our x terms, we have a plus x, a minus 4x, and a plus x. So we have 1 minus 4 is minus 3, plus 1 is minus 2. So it's minus 2x. And then, let's see, we have a positive 2 and a minus 2. They cancel out. So we're left with 2x squared minus 2x, and that's choice A. Choice A. Problem 43, I think we can fit in here. Let me copy and paste it. Okay, copied it, and now pasting it. Okay, it says a volleyball court is shaped like a rectangle. Let me draw that. Well, I didn't want to draw it filled in like that, but fair enough. Shaped like a rectangle, it has a width of x meters and a length of 2x meters. Okay, so its width is x, and it's, let me write, this could be x, and this would be 2x, because it's longer. Which expression gives the area of the court in square meters? Well, the area is just the width times the length, right? So it's just x times 2x, which is equal to 2x squared, right? That's the same thing as 2 times x, which is the same thing as 2x squared. And that's choice B. Anyway, see you in the next video.